Welcome back to my channel Electronic Science Tutorial. This is the 16th class of Operational Amplifier. Today I will discuss the comparator circuit by using an op-amp. This is the most important topic of Operational Amplifier. Okay, so without any time waste, let's start our class. What is comparator circuit and how this comparator circuit is designed by an op-amp? A comparator using an operational amplifier is a fundamental circuit in analog electronics which is used to compare two voltage levels. When the voltage at the non-inverting, that means positive terminal, is greater than the voltage at the inverting input, that means the negative terminal, the output of the op-amp swings to its positive saturation voltage. Conversely, when the voltage at the inverting input is greater than the voltage at the non-inverting input, the output gives negative saturation voltage. That means when the voltage at the non-inverting input terminal is greater than the inverting input terminal, the op-amp output of the op-amp goes with positive saturation voltage, and that in the reverse condition, that means when the voltage of the inverting input is greater than the non-inverting input terminal, the output of the op-amp goes to negative saturation voltage. So what is the basic components of comparator circuit? First of all, operational amplifier, that is op-amp. We have to use two resistors. One is input resistor and one resistor is used for reference voltage. Okay, if needed. One power supply for the op-amp, that is typically plus minus VCC, which is value is nearly about plus minus 12 volt or plus minus 15 volt we have to use. Right, so these are the basic components of the comparator circuit. And this is the basic definition of the comparator circuit. Right. Now, the steps how we design the comparator circuit. First of all, choose the op-amp. We have to select an op-amp that suits our voltage level and speed requirement. Commonly in laboratory we have choose LM741 op-amp, okay, for high precision. Next, we have to choose the power supply. Generally we have to use plus minus 12 volt power supply in the laboratory. Next, we have to choose the input, that is V in. This is the voltage you want to compare. Next, V reference. This is the reference voltage against which V in is compared. It can be set using a voltage divider from the power supply or any other stable reference source. Right. Next, what is the operation? That means if the input voltage is greater than the reference voltage, then what is the output of the op-amp? That means first condition is if V in is greater than V reference, the output voltage of op-amp will driven to plus VCC. That means positive saturation. And the second condition is if V in is less than V reference, the output voltage V out will be driven to minus VCC, that is negative saturation voltage. Okay, so these are the two conditions for comparator circuit of by using an op-amp. The two inputs are required. One is V in and the other one is V reference. One power supply we have to choose and one suitable op-amp we have to choose for high precision. Okay. So this is the basic comparator circuit by using an op-amp. Now, what are the considerations of for designing a comparator circuit by using an op-amp? First consideration is hysteresis. To prevent rapid switching or noise issues, hysteresis can be added by feeding back a small portion of the output to the non-inverting input terminal. This is the first consideration to produce or to generate a comparator circuit by using an op-amp. Next is response time. The response time of the op-amp is crucial for high-speed applications. Next, power supply range. Ensure the op-amp can operate within the provided power supply range. So these are the basic considerations to generate a comparator circuit by using an op-amp. So the basic comparator design can be used in various applications like zero crossing detectors, level shifters and many more. For more complex needs, additional circuitry can be added to refine the behavior and the performance of the comparator circuit. So these are the basic comparator circuits. First of all, the definition of the first we have considered the definition of the comparator circuit. Next, we have to talk about the basic components of the comparator circuit. Next, how or what is the step to design one comparator circuit by using an op-amp. Next, we have to consider what are the considerations we have to take to design a comparator circuit by using an op-amp. And then we have talk about the various application of the comparator circuit by using an op-amp, that is zero crossing detector, level shifter and many more. And for complex needs, additional circuitry can be added to refine the behavior and the performance of the comparator, right? So these are the basic comparator circuit by using an op-amp. Okay. Thank you. If you like, do like, share and subscribe my channel. Thank you.